Okay, the next skill we're going to look at is Venn diagrams, and these are really kind of crossover material for the higher paper. They are relatively straightforward once you get your head around the language and the notation of them. Mathematically they're quite straightforward, so it's really worth trying to nail these and pick up some of the more difficult marks on the paper. So we're going to have a look at a question. Set A is multiples of 3 and set B is multiples of 2. The universal set with this funny squiggly zeta symbol is the numbers 1 to 9. Okay, so let's stop there and just think about what that means. So the universal set is the numbers that I'm interested in. What I'm going to do is I'm going to try and see which of them are multiples of 3. So I'm going to start by saying A is equal to, and just when I'm listing elements of a set I use these funny brackets. So multiples of 3 from that universal set is 3, 6 and 9. Multiples of 2 is 2, 4, 6 and 8. And the universal set is 1, 2, 3, 4, 5, 6, 7, 8 and 9. And the Venn diagram gives me a nice easy way to sort that information. So let's have a go at sorting it. The way I do it, my sets are always circles, and then around it I put my universal set, which is the rectangle. So let's start by filling in from the middle. So is there anything which is in both A and B? Well, the only number which is in both A and B is 6. So I'm just going to cross 6 off all of my lists, and I'm going to put it here, and that's in both circle A and in circle B. Let's have a look at what else is in circle A. It's going to be 3 and 9. So let's just cross that off the other list that it appears on, 3 and 9. I've then got to put 2, 4 and 8 in circle B. 2, 4 and 8 go in there, making sure they get crossed off this list so that I know they've been used. 2, 4 and 8. What I should be left with is just simply 1, 5 and 7, and they go around the outside. Now I'm going to just pause there. So once you've got your Venn diagram completed, it's always worth making sure that you've listed all your numbers from the universal set, as that's often a place where people lose marks. So let's just count through. 1, 2, 3, 4, 5, 6, 7, 8, 9. Everything's in there, nothing's in there twice, everything's in the right place. So we've got our completed Venn diagram. So we're going to go on to have a look at part 2, which is calculate NA. NA means the number of elements, the number of items in A. So the number of items in A is just one, 2, 3. There are 3 items in A. So NA equals 3. Part 3. Calculate probability of A intersection B. Okay, so let's just take a second to have a look at this symbol. This one means intersection. That means in both A and B. So if we look at a Venn diagram, the intersection is going to be that bit there. That's the intersection of the two sets. So in both A and B, I've got the only number in there is my 6. So the probability is going to be, there's one number in there out of 1, 2, 3, 4, 5, 6, 7, 8, 9 in total. So the probability of picking a number which is in both sets is 1 out of 9. Calculate N of A union B. So the number of elements in A union B. Now here, it's the opposite, it's the upside down version of intersection, and that's called union. In either A or B or both. So looking at our Venn diagram, A or B or both means this whole thing. That's A or B or both. So I'm looking at how many, number rather than probability. I've got 1, 2, 3, 4, 5, 6. The number in A or B or both is 6. The last one asks for the probability of B dash. So 5, probability of B dash. Now the dash is the complement. It means not in B. So if we think, here's my A and here's my B, everything which is not in B is just the outside of that B circle. So everything that's not in B. So probability of not being in B, well, let's have a look. What's not in B? 1, 2, 3, 4, 5 numbers aren't in B. So probability of being in B dash is 5 out of 9. Okay, just pause the video there while you take down that worked example. A lot of information to take in there. Just before we go on, we're going to try one more worked example, which is a very common GCSE question. So I've got 15 students who asked if they like Coke or Pepsi. 4 like neither, 8 like Coke, 5 like Pepsi. How many like both? And here we're going to use a Venn diagram to help us with that question. So I've got my Pepsi and my Coke, and my universal set. Now here I'm going to populate this with numbers. So I know the 4 like neither. And it's got to add up to 15 in total. So I know that all the rest of this has got to be 15 take away 4, which is 11. Now my problem here is I've got 8 liking Coke and 5 liking Pepsi. So I've got 15 take away 4, which is 11, but I've got 8 plus 5 equals 13, so I've got a problem here, which means that I must have double counted some of those people. Well, the difference between my 13 and my 11 is 2. So let's just have a look. If I say that 2 people liked both, I know that 5 liked Pepsi in total, so 5 in total like Pepsi. I've already got 2 who like Pepsi here, so I must have 3 who like Pepsi here. 8 like Coke, I've already got 2 who like Coke here, so there must be another 6 who like Coke. Let's just check that that works. If it does, then this should add up to 15. 4 plus 6 is 10, plus 2 is 12, plus 3 is 15. So how many like both? 2 like both. Pause the video now, take down that second worked example, and then when you're ready we can go on to some questions for you to try. Okay, so the first example really questions your understanding of set notation, and then the second and the third are some real life examples. Pause the video now, give them a go, and when you're ready press unpause and we'll go through the solutions.